Hey everyone, Mr. Hauk here. In today's video, we're going to be looking at the Unit 5 section of the Semester 2 Final Exam Review for Pre-Cal. Let's go ahead and get started. So here in problem number 6, we have a problem where we have this guy, Jamal, that is looking outside of his house at two different sides of a lake, and he wants to find out how far across, or what is the distance from one end of the lake to the other. And here I have the triangle set up for it. So this video, by the way, is going to be like the previous video where I'm not going to be working through them from scratch. Instead, I already have all the work worked out here on my key. And I'm just going to be talking through the problems and just kind of explaining what I was doing and the justification for these steps. So here's our image. For these problems, these oblique triangle problems, you pretty much always want to draw a picture. So we have Jamal here, and looking at one side of the lake, we can see the distance is 160 feet. Jamal to the other side of the lake, the distance is 215 feet. And we want to know this distance across the lake. So for a lot of these problems, for pretty much all of them, I like to go ahead and look at the kind of triangle that I have and determine what tool to use. So from the beginning, we have a side, and the included angle. Included meaning it's the angle in between the two sides. So we have a side angle side triangle. And if we look at our Unit 5 conics reference sheet, when we're given a side angle side triangle, we need to use the law of cosines. So that's what I did here. I set up the law of cosines with the information we have. For the law of cosines, notice that we have our three sides. The side we're looking for is x, then 160 and 215. So I'm going to put x over here, the side I'm looking for. Here's the other two sides. We end up squaring them and adding them together. Then we do minus 2 times those other two sides again, these two same sides, times the cosine of the angle that's across from the side that we're looking for. So this is how everything gets set up with this law of cosines problem. All of this stuff you can simplify, use your calculator, and you get 34,353.83. Now this is for x squared, so of course we take the square root of both sides, and that gives us that x, or the distance from one end of the lake to the other, is 185.35 feet. All right, in problem number 7, we want to find the area of the triangle ABC, given that side B is 13, angle B is 92 degrees, and angle C is 38 degrees. Now, first things first, when we're trying to find the area of a triangle, you need to remember that in order to find the area, you need to either have two sides in the included angle, or you need to know all three sides of the triangle. And in my image here, the values in black are the original values. So originally, what we know is an angle, and a non-included side. So we know side angle, or angle side, same thing. So we have not met either of these two criteria. And what I'm thinking, at least when I work through the problem, is that if I could find this side, side A, then I would have a side angle side, which means I could use my area formulas. So that was my thought process. Let's use the law of sines to find this side of the triangle, put us into a side angle side scenario so I could use my area formula. So that's what we do here. We set up using the law of sines. Sine of 92 degrees over 13 is equal to sine of 50 degrees over it will be 9.96, but here we would say it's A. We don't know it's 9.96 yet. And by the way, let's talk about that 50 degrees real quick. We were not given this initially, but we know that the angles of a triangle add up to 180 degrees. So 180 degrees minus 92 minus 38 gives me 50 degrees for this angle right here. Okay? So that's what we have. So now, again, setting up the law of sines, we have sine of 92 degrees over 13 equals sine of 50 degrees over this side A. Then cross multiplying, we have A times the sine of 92 degrees equals 13 sine of 50. Let's divide both sides by the sine of 92 degrees, and we get that A is 9.96. And now that we know side A is 9.96, we are in a side angle side scenario. And then we use our area formula. So the area formula says 1/2 times those two sides times the sine of the angle in the middle of them. And we plug that into the calculator, we get that the area of this triangle is 39.86. We weren't given any units, so you can either just leave it as 39.86, or you can say 39.86 units squared. All right, problem number 8, and this one is actually, you need to be careful with this one. So it says to solve the triangle DEF, given that side D is 17, side F is 13, and angle E is 34 degrees. And here the values in blue are my original angles. So notice we have a side angle side triangle. Side angle side means we're going to be using the law of cosines. Now the reason you have to be careful with this problem is because it's a little deceptive. We have to use law of cosines to find the first side. So that's what we do here. Set up law of cosines just like I did in problem number 6. So e squared equals 13 squared plus 17 squared minus 2 times 13 times 17 times the cosine of 34. Take the square root of both sides. We get that the side across from angle 34, side E, is 9.57. Now here's where you have to be careful. Some students might be tempted to use law of sines to finish the problem. And if you do this, you run the risk of putting yourself into an ambiguous case scenario. So since we started with the law of cosines, if you want to stay safe and not end up in an ambiguous case scenario, if you start with law of cosines, as long as you continue to use law of cosines to find the other pieces, you're not going to run into the ambiguous case. So that's what I did here. We started with law of cosines to find side E. Now that I have side E, I can find angle D and angle F. And I'm going to use law of cosines to find angle D next. So that's what I do here. Notice that angle D, the angle that I'm looking for, is right here, which means that side D, which is 17, has to be on the opposite side of the equation. So I plug in the pieces, we simplify. 17 squared is 289. 9.57 squared plus 13 squared is this 260.5849. And this negative 2 times 9.57 times 13 is this negative 248.82. Rearranging the pieces, subtract this over to the other side, divide both sides by negative 248.82, and then to get angle D by itself, we have to take the inverse cosine to remove this cosine. And that would give us 96.56 degrees. Once I have that angle, 96.56 degrees, and we already had angle E, 34 degrees, I can subtract both of those from 180 degrees to find the final angle F, which would be 49.44 degrees. All right. Problem number 9, another solving the triangle problem. However, this one is going to be a little safer than problem 8. So looking at number 9 here, we have triangle PQR. We have all three sides. So P is 21, Q is 16, side R is 26. This is a side triangle, so we're going to need to use law of cosines to at least start the problem. And one of the things that you really want to be careful with is when you use law of cosines to find an angle, you want to be finding the largest angle first, okay? So we can see that 26 is the largest side, which means angle R is going to be the largest angle. That's the angle that I start with first. Again, here's angle R, so I know this over here needs to be side R, and then these are just going to be the other two sides. So we go through, solve, for angle R, just like we did up here, just like we solved for angle D in this case, solve for angle R, you get 88.2 degrees. Once we know angle R is 88.2 degrees, we need to find the other two angles, angle P and angle Q. At this point, you can use law of sines, because since we found the largest angle first, everything is going to be okay. As long as if you find the largest angle first, you're fine. You can use law of sines next. The reason it was such an issue in number 8 is because the angle that we had available to us, 34 degrees, was not the largest angle. But here we found the largest angle first. We found 88.2 degrees, and we knew it was the largest angle because it was across the largest side. So here you can use law of sines without running the risk of getting the ambiguous case, which is what I did here. I said the sine of 88.2 degrees over 26 is equal to the sine of P over 21. Cross multiply and solve for P, we get 53.8 degrees. And once we know angle R and angle P, we subtract those both from 180 to get angle Q. All right, last problem is number 10 for conics at least. And number 10 is going to be like your free response from the the oblique triangles test. It's going to be like your free response oblique triangle question on the performance final. It's going to be one of those ambiguous case 2 triangle problems. So here's our initial setup. Side A is 29, side B is 24, angle B is 17. We can see we have a side-side non-included angle, which is going to give us the ambiguous case in this problem. Ambiguous case meaning we're going to have two triangles. So let's solve for these two triangles. The first triangle is pretty normal. You're going to solve it just like any other solving a triangle problem. Here, when we're looking at our initial pieces, we have angle B and side B. So that's going to be part of our problem, sine of 17 degrees over 24. And we have side A, so we have to find angle A first. So we have sine of angle A over 29, cross multiply and solve for angle A, and you get 20.69 degrees. Here's, of course, the steps if you need to see the steps for that. Once we have angle A, well, we already had angle B, so we'll subtract angle A and angle B from 180 degrees to give us angle C, which is 142.31 degrees. And once we have angle C, then we can find side C. So now we're going to say sine of angle C over side C, which is now what we're trying to find, divided by sine of 17 degrees or equal to sine of 17 degrees over 24. Okay, cross multiply, solve for C. You get C is 50.19. Now we have to find triangle number 2. And this is something that everyone just has to remember. For triangle 2, you take the very first angle that you solved for in triangle 1, and in triangle 1 we had to solve for angle A first. We had no other option. So you take that angle, in this case angle A, and the new angle A, or angle A prime for triangle number 2, is going to be 180 degrees minus the old angle A. So 180 degrees minus 20.69 degrees is going to give us the new angle A prime, which is 159.31. Once you have your new angle A, and remember that for the second triangle, the original pieces are still there. So angle B for the second triangle is still 17, side A is still 29, side B is still 24. So now that, angle B prime and angle B are the same thing, they're both 17 degrees, and now we have angle A prime. This means that we subtract those two from 180, and that gets us our new angle C, or angle C prime. And once we have our new angle C prime, we use the law of sines right here to find side C prime, our new side C, and we get 5.28. So with this being a double triangle problem, here's the answers, the solutions to both triangles. Again, notice I have to emphasize again that the starting information, side A is 29, side B is 24, angle B is 17, is common in both triangles. It has to be. The other pieces, angle A, angle C, and side C is what's different between the two triangle solutions. Okay? So these have been the problems from this oblique triangle section of the final exam review. And hopefully they made sense. If not, make sure that you ask one of your teachers, one of us, either me, Mr. Moskowitz, or Coach Smith, for help. All right, have a great day.